Hey guys, so this is the first P3 replay. It is for lesson 2 POTDs and it's from the 8 a.m. discussion. In this particular problem, the idea was to match up columns in an eigenvector table with orbital shapes A, B, C, and D. So it's a ranking problem in ACE where you're asked to take the four MOs A, B, C, and D and match those up with the columns in the eigenvectors table, which you'll see in a second. So the student in this case started on the problem and is just given the directions, sort of a once-over. And here's the corresponding web page that goes along with it. So he's gone ahead and pulled up orbital A. He's taken a look at that. Now he's switched to orbital B. And this is a good idea to sort of see what's in front of you for an exam problem and see where you can get the most information. So he's looked over the four orbitals, and now he's taking one more look at the molecule itself. And now we switch back to orbital A and taking a look at the directions again. So as a TA, I would look at this and say, he's doing a great job so far. So he's chosen an orbital that actually provides a lot of information here, right? We can see the p orbitals pretty clearly. So he should be looking for p coefficients in the LCAO table. And you can see him scrolling his mouse over the PZ row there. That's very good, looking for that PZ coefficient on carbon number 2. And now he switched gears to another orbital and yet again to orbital D. So kind of not really committing to that one orbital that he started with. Especially for matching or ranking problems, it's a good idea to stick with one molecular orbital, right? Stick with it, get as much information out of it as you can, and if you don't think it's giving you a lot, then switch gears, and that's exactly what he's done. So he went ahead and chose column 1 for orbital D. Now he's taking a look, it looks like, at the remaining orbitals to see where he's going to get the most information out of those remaining orbitals. So he appears to be noticing in orbital C that there's a significant coefficient from py orbitals on the carbon atoms, which is good. Sort of hard to tell what he's seeing at the moment. But he's gone ahead and chosen LCAO 3 for molecular orbital B, which is the one we're looking at here. Let's see where he goes from here. So boom, I'll pause it right here. Notice that he's got his mouse right over that key LCAO for PZ on carbon 2 contribution. So it's a little bit hard to see on the left-hand side of the screen here, but that PZ orbital right there is absolutely key, right? A huge contribution from the PZ orbital on carbon 2. That's a dead giveaway that molecular orbital A corresponds to LCAO 4. So here's yet another key point in the problem-solving process, right? If you get a problem incorrect, especially for multiple choice and fill-in-the-blank problems, the temptation to guess can be overwhelming. I would advise against that. Go back and apply systematic reasoning the way you did probably the first time you went through the problem, and diagnose your errors as best you can. That's hard to do on an exam because you don't see a lot of feedback, but run through the process of your thinking again and try to identify points where your thinking may have been incorrect. So now he switched orbitals A and C and submitted. Still incorrect, but you'll notice that he took barely a cursory look at orbital C, and he isn't going back and really reevaluating his thinking as he should. He sees that very large PZ coefficient in LCAO2, and he recognizes that that's an important part of the problem, but let's see if he can apply that to the molecular orbital pictures in the JMOL window. Now in this particular orbital, for a second there, it looked like he was focusing on the PZs, which in this case is incorrect because the P contributions are primarily along the x-axis rather than the z. So very important to sort of know what you're looking at in a problem like this. And indeed, in a lot of MO problems, that's pretty huge. And we see, unfortunately, his time has run out. So again, some important take-home lessons from this P3. Apply systematic reasoning throughout your attempts. Don't resort to random guessing, even when time gets tight. If time gets tight on a problem and you don't think that you have time to apply systematic reasoning, then my advice would be move on. Or if you feel overwhelmed by the temptation to guess, move on. Move on with your life, come back to that problem later, and hopefully you'll have a chance to get it later on.